And hello everyone, Heinz here. Gonna talk about Axel F. Let's take a look at the whole thing. Yep, this is the whole thing. I used to have this cube room around the whole thing, but I decided to just hide it during renders because it wasn't actually doing anything. Anyways, it wasn't receiving any light anyway, so it would have just appeared black, and it was slowing down rendering, so I just hid it. And oh man, I was staring at this geometry for hours and hours and hours. So the first thing you may notice is that there are a ton of lights in the scene. In fact, select all by type, light. There are a lot of them. And the reason I had so many is that Animusic animations are lit like it's a stage. Here, let's go to stick figures. You see how he's being lit by a spotlight? Right here. Let's skip forward. These horns, they're being lit by a spotlight and it's shining on the wall. And you see these spotlights here, they're different colors. That's a classic stage lighting trick. You're supposed to have two different light sources from the front and another contrasting color light source from the back. Like warm lights from the front, cold lights from the back, to give it more pop and definition. And all of the if you've ever wondered why all the Animusic animations are at night, the ones that are outside are at night, or dusk in the case of Pogo Sticks, it's because if it were in full sunlight, it would ruin the stage lighting. The stage lighting also helps to give more emphasis to certain parts at different times in the song. And I did that with my animation. Let's switch it to rendered, and actually let's switch to Eevee so it renders faster. Alt A, there we go. So I lit up different parts during different times, and each instrument has its own group of spotlights, which overlap and have different colors. You can see this one is more orangey, this one is more blue. And these random colorful spotlights, they're to visualize that string part in the background. That string part in the background, that was how I visualized it. Because every part in the song needs a visualization. Oh, and also speaking of the song itself, let's talk about how I made the MIDI file for this animation. Alright, I think I got it working. Linux audio is kind of a mess sometimes. Anyway, here is the Ardour file I created. Here's the original track I just imported into Ardour, and then I created a bunch of MIDI tracks with all the instruments. I'm going to mute this tempo track. Oh, talking about this lead synth sound. Oh, man. You hear how in the original song it's got this kind of sharpness, depth to it? I have found that sound is impossible to recreate. Listen to this. Not even close. I cannot figure out how to... Someone who's a better audio engineer than me can probably figure it out, but I can't. So that's why I used the original song and not a remix. If I had used a remix, this workflow would have probably been easier. But anyway, let's zoom out and look at the whole song. Here are the drum parts, and here's the ticker. I had to listen very carefully in order to transcribe this. In the animation, it's the finger things that spin around in that circle. You hear that ticking sound in the background that's different pitches. It sounds kind of like a synthetic wood blocks. This is what it sounds like in my... I imported the song into Audacity, slowed it way down, and used LOMS to transcribe the notes, and then I just copy-pasted them into here. It doesn't really matter that it doesn't sound right because this isn't going to be heard anyway. It just matters that the notes are in the right places. You might have seen this Dupla Razor and Dupla Bass and Dupla Hex. Dupla Razor, I had to make this track as a copy of this other one because for some reason the MIDI wasn't working. This Dupla Bass, you see how these notes are different velocities? These notes are for the left hand and these notes are for the right hand. That's how I split them up using velocity. I could have made two different tracks, but this one was... It may not have been actually easier this way. Anyway, this Dupla Hex is used for an even more different purpose. I used both these tracks in the animation. This one, I only used the Dupla bass. This bass track went unused. I just made it when I was transcribing the actual song, and then I copied it and changed the velocities. This Hex track here contains the chord notes. And this track contains just the notes being played by the robot. He's only playing one note at a time, so this track controls the beams, and this track controls the robot's hands. And then I have these string and bell parts, and bass drum, snare drum, hi-hat, shaker. I already talked about the tickers, the clappers, those are this part. And the toms, which only play at one point in the song. Didn't bother to make an actual tom sound for it. And this tempo track, it goes throughout the entire song. It goes throughout the whole song, and it never changes. It's just the global tick track for the whole song. And the reason I had to add this is because you see these tempo changes up at the top? They're very, 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 very slight tempo changes. But I had to add them because I wanted to match the song exactly. And if I hadn't added them, it would have added up to a noticeable difference. Once I had made this, there was no way to actually get it out of Ardour as a MIDI file. I could export the audio just fine, but Ardour can't export an entire song as MIDI. So what I had to do instead was use this patch bay here. I don't have Rose Garden running right now, but I also had to have A2J MIDI D running in order to be able to convert the also MIDI to Jack MIDI so that Rose Garden could actually use it, capture it. I had a Rose Garden recording right here, so I would just wire the track MIDI output into Rose Garden, and I would record one track at a time, rewind, play the whole song, connect the next track, rewind, play the whole song, connect the next track, rewind, play the whole song for every single one of these tracks. Ardour, if you just created a MIDI export function, that would be great. But now let's look at the actual MIDI file. Alright, this is the actual MIDI file that I used to create the animation. And if I open it up here, you can see that the notes aren't actually aligned to the tempo grid, but they're all perfectly aligned to their own internal tempo, and that is all that matters. And they're both perfectly aligned with the tempo track. The tempo track isn't aligned with the note grid, but it is aligned with all the other tracks, and that's all that matters. So now let's go back to Blender. So now we're talking about the Blender file, and this was how I did all of the animation. No, sorry. This is how I did all of the automatic animation, auto musical animation. I wrote a bunch of Python scripts. A bunch of Python scripts. But let's look at this one, the hex hand script. This instrument is called hex. I don't know why I called it that, but maybe because, oh, these are hexagonal. I don't know. There are a lot of hexagons in this environment. That's just a style choice I made. Because hexagons are the bestagons. Actually, I don't think that's true. Hexagons are not the bestagons. I actually like pentagons a lot better. But anyway, import bpy. This module is the Blender Python interaction interface. It contains all the data and functions that allow you to insert keyframes and access the data of objects and that kind of thing. Import math. I use math. Mido. This is the module I use to import MIDI files. Sys, then syspath append, so I can import animidi, then import lib, and then reload animidi. I don't know why this was necessary, but I had to reload the module in order for it to work properly. It's probably because this is a downloaded version of Blender. It's not using the system Python path. Alright, the MIDI file and load track. This is a very important function. It loads the track from the MIDI file with a track index. I also wrote a script that calculates how many different notes are in each track of a MIDI file. That was very useful for making this, because I needed to know that the razor part, I call this part razor, the razor part has exactly 9 notes, and the bass part has, oh, I forget, either 19 or 20 notes, 16 unique notes. And this one doesn't actually use all the notes, which is kind of heresy, but I don't know. And Bell 5 track, hex pads. This is an object set manager, which is another function I created. It's used for controlling all of these as one group, and it allows you to index. Oh man! Oh, look at this! I put the wrong material on these ones. I didn't even notice that until just now. Ugh, stinking. These ones don't even have a material. That's just the default material. Duh. Let's just pretend that didn't happen. Anyway, Object Set Manager. It allows you to define which MIDI notes go to which objects. Alright, and I also have an Object Manager for the strings. Scene. That line is necessary for inserting scene markers, which are useful for debugging. LHand is bpy data objects lhand.002. That's this one. Again, bpi, that's the Blender Python interaction module. Alright, now I split the track into left and right hands based on their velocity. I also do that for the Bell 5 track. Exclude frames. This, a lot of people have asked about this. This is the function that allows me to switch between manual keyframing and automatic keyframing. So if it's between 1608 and 2200, return false. Let's go to frame 1608. Yeah, right here when he starts, when he hits all the strings, that I keyframe that manually, and all of this, the part where he reacts and runs over here, kind of gropes a little at the box, can't quite get it open, and then yeah, bam, timed on the exact note that happens. And then he talks to the other guy and then plays the strings kind of hesitantly. I did this, keyframed this manually as well, animated it manually. And then here at frame 2200, there, just standing still, not doing anything. So that's the part where the script kicks back in. Remove object keyframes. That's a function I wrote so that I don't have to redo so that I don't have to delete all this animation every time I want to rerun the script. It just deletes all the automatic keyframes and redoes them, so the new ones don't overlap the old ones and cause glitchy behavior. I had to have a function like this because if I just delete all these frames, then I just deleted all the animation for that hand as he's doing that part. So we couldn't have that. This function takes into account the exclude frame range. Here we have some resting positions, out of the way positions, positions for diddling. I should probably explain that here. At this specific point, right there, he's hitting the same note with both of his hands, and so I scripted it to make them move out of the way of each other so they didn't clip through each other quite as badly. I mean, they still kind of do. There isn't no clipping in any of the Animusic songs. They're very good about making sure that nothing clips through each other. But I wasn't quite that strict. You can see here the elbow clips through itself. This here, that's just the armature. I can hide that. Oh, speaking of the armature, this is all done by inverse kinematics. So if I move the hand here, you can see the arm just follows along with it. That's inverse kinematics done using the armature. So I didn't have to animate the arms and arm positions. That would have been a whole huge rabbit hole. So I didn't need to do any of that. Man, I love inverse kinematics. Alright, here is the main loop for note in Hextrack. Hextrack is just basically a list of notes. So we get the next note and the previous note. This get next note function. This is quite important. It gets the note in the track after the given note, the note you specify. It gets the next note after that. And you can specify the direction, next or previous, and you can specify if it matches the same note value or not, which is useful in some situations. And this val function, you can make this anything you want. This function here returns true if the note hand is the same hand, else false. this is... I need to do this because the hand needs to use only the notes for that one hand. So this allows me to sort them out. And then next adjacent note, previous adjacent note. I needed that for the hands moving out of the way thing. Current note object. This is how the hands know where to go. Because I didn't set a bunch of positions for all of these. I just used the position of the objects themselves because Blender knows where these objects are, so I can just use those coordinates. And this is from the object set manager, get object by MIDI note, because each object has a MIDI note assigned to it. So you just get the certain object, and then I can calculate where the hand needs to be in order to hit that, using an object offset and the length of the hand right here. And then some trigonometry. Gets kind of complicated. I also did that for the Razorbot's hand animation. It does the same kind of thing. By the way, these beams are black just because the rendering engine right now can't handle transparency. This is just the default material preview render. If I change it to cycles, it goes away. That's why these beams are also black. So then we insert a keyframe. Insert multi-keyframe. Let me find an example of... Insert keyframe. Here we go. This is the most important function in the entire library. Insert keyframe. That's literally all this library is built to do. Insert keyframes. So, note.note on. This is the frame that the note becomes active. And then the note off event is when the note turns off. That's what the import track function does. It changes the values of the note on and note off to be frame times instead of MIDI note tick times. And that's why the MIDI file didn't need to be aligned to the tempo grid, because it's the same either way. I think that's about all I have to say for this script. Obviously there's a lot more to say, but it's so complicated, and I don't want to bore all of you. If you want to go through this script in detail and figure out exactly how it works, I've put a link to the download of this Blender file in the description. So now let's talk about this xylophone part. I made a script to... Let's just run this. And then there we go. It resets it into its default state. Because I didn't want to have to model every single one of these keys manually, because it was just too many of them, and they needed to be precisely scaling down by a certain amount each time, and I didn't want to have to do that manually, so I made a script to do it. Xylophone creation script. By the way I'm running all of these is with the keystroke Alt-P. So this script is now running. Thinking about it. Waiting some more. And waiting and waiting and still waiting. It takes a while because Blender has to calculate the position of all of these. See if you can hear my computer is heating up. It's a lot of complicated calculations that I'm making Blender do right now. There we go. Ta-da! Oh, by the way, all of these, if you look real close, there aren't any... I didn't bother to model the strings holding the keys in place. They're just kind of floating there. Just being kind of lazy on my part, because I didn't want to have to add the strings to the script. By the way, if you're wondering how these glow, it's just I'm animating this glow strength value on the principal BSDF node. And now let's talk about these wires. You noticed how many wires there are? And electrical equipment, select objects. Look at all of these cables and cable boxes. I had to model all of these. I wanted to do cloth sims for these cables, but it never quite worked right, so I ended up having to model them by hand. And these are just spline curves. I modeled every single one of them by hand, and it took a long time. But I just had to add them because otherwise it just would have looked kind of bare. Oh, actually it looks a lot cleaner. Let's talk about the floor texture. This hex tile texture. This is a pretty complicated shader, but I'll explain it. So here we have a noise texture. It's a big noise texture. And then we have a small one to add more detail on top of that. And we're just mixing them together. This one has a color ramp to kind of clamp it. And then they're going into this bright contrast node to kind of change the color a bit. And then they're going into both the base color and the roughness of this BSDF, so that's how you get the shine on it. And then we have this hex tile texture that you can see right here. It's going into this mix shader, and it's also going into this bump node to add some sort of a little definition, make the tiles pop out a bit. And then we also have this other BSDF shader for the grout between the tiles, which is just a flat gray. And then both of these BSDFs are going into this mix shader, and the factor is this hex tile texture. So the black parts get mapped to the gray, and the white parts get mapped to the tiles. I thought that was a pretty clever kind of shader. And now let's talk about the cameras. I was going for a kind of mix of handheld camera moves and kind of sweeping wide shots like this on a boom, which is kind of like the Tabernacle Choir videos, where they have a mix of handheld close-ups and far-away sweeping boom cam shots. What else is on my list of things to talk about? Oh yeah, let's talk about this drum bot. I took a different technique to animating this guy. See all these empties? They're important because of their position. Because I didn't want to have to dictate exactly where the hands should be with lists of numbers in the code, because that would be super tedious. So I did this instead. It's called insert position keyframe, and what it does is inserts a keyframe at a specific time, and the target object is the hand, and you also have another object, which is the object you want to use the position of. So it'll insert a keyframe at that time and in that place. So that's how I did that guy. I wanted to give you a close-up look of this instrument right here. This is the ticker part. Believe it or not, this is the most complicated script in the entire video. I wanted them to be able to move all the way around in a circle and not just go back and forth on a certain range. I wanted them to be able to go all the way around if they needed to. So I had to make a bunch of functions and a bunch of debugging print statements. for every node of the animation, it calculates which of these is the closest, and it summons that to play it. I'll skip to the part where they start moving. Somebody said in the comments that this looks like the tentacle beast in the blast pit from Half-Life, and I didn't even think of that when I was making this, but yeah, it kind of does look like that. And the last thing I want to talk about is something Wayne Lytle said in the commentary of Heavy Light.
It's funny because there's sort of a couple of misconceptions out there. One is the sort of the myth that Animusic is Wayne Lytle, and it's something that I do on my spare time on the weekends on a laptop, and it's real easy and quick, and I do it for fun in my spare time. And
that's me. I am literally that guy. I do this on my laptop in my spare time on the weekends. And it's Blender that's allowed me to do that. Blender has done most of the hard work already. Well, with the rendering and the modeling and the animation, I don't have to worry about the details of any of that. I just program Blender to do what I want. It's not real easy or real quick, but I like doing it. Anyway, thank you all for watching. See ya.